February 20th, 1943, north of Kasserine Pass, Tunisia. What the German Panzer commanders observed that morning would never be fully conveyed by after-action reports or intelligence summaries. Through drifting dust clouds and the smoke of burning vehicles, American M4 Sherman tanks executed coordinated maneuvers that violated everything German armored doctrine insisted was impossible without visual control. 5 Shermans advanced across broken terrain, separated by ridgelines and depressions that eliminated all direct line of sight between them. No signal flags were raised, no flares burst overhead, no messengers raced between vehicles, and yet the tanks converged on German positions with precision timing that appeared almost unnatural. Each American tank moved as if guided by a shared awareness. Blind sectors were covered automatically. Approaches overlapped without collision. Crews adjusted position in response to movements they could not physically see. Every commander knew exactly where his neighboring tanks were located, even when terrain and smoke made visual contact impossible. To German observers inside Panzer IVs, this coordination bordered on the inexplicable. Inside German tanks equipped with FUG-5 radios, commanders struggled to hear even their own platoon leaders. Static overwhelmed their amplitude-modulated transmissions. The 10-watt FUG-5 sets, considered advanced by late 1930s standards, lost clarity as soon as tanks began moving. Engine vibration, ignition systems, and track noise generated electrical interference that drowned out voices. In most German units, only command tanks carried full transceivers. The majority of Panzer crews operated with receivers only, unable to transmit what they saw, request support, or warn others of threats. The Americans were using something the German army had not realized existed. Every Sherman tank carried a frequency-modulated radio system. Each set transmitted at 25 watts. Each unit possessed crystal-controlled stability that eliminated drift and interference. Voice clarity cut through battlefield noise with startling sharpness. Orders, warnings, and targeting information flowed instantly between vehicles. 8,000 kilometers away from Detroit assembly lines, the most decisive technological advantage of armored warfare was revealing itself, not through armor thickness or gun caliber, but through invisible electromagnetic waves binding American tank crews into a single coordinated force. That advantage had begun taking shape long before the first Sherman reached Africa. On July 22, 1941, the United States Army standardized radio equipment for all medium tanks. The Signal Corps approved the SCR-508, SCR-528, and SCR-538 radio sets as mandatory equipment for armored units. While German forces advanced into the Soviet Union using radios that relied on amplitude modulation, engineers at Galvin Manufacturing Corporation, soon to be known as Motorola, were completing a technological leap that would quietly overturn German battlefield assumptions. The project brought together some of America's most capable radio engineers. Daniel E. Noble recognized that frequency modulation could solve the interference problems that plagued mobile radios. Henryk Magnuski, Motorola's principal RF engineer, overcame the challenges of installing sensitive electronics inside armored vehicles subject to shock, vibration, and extreme temperatures. Their final system weighed 181 pounds and transformed every Sherman tank into a communication node within the first true battlefield network. At the heart of the SCR-508 system was the BC-604 transmitter. producing 25 watts of output power, 2.5 times that of the German Fug-5. It operated in the 20.0 to 27.9 MHz range. 10 preset channels, stabilized by quartz crystals, ensured precise frequency control under combat conditions. 2 BC-603 receivers allowed commanders to monitor multiple channels simultaneously, maintaining contact with both platoon and company networks at once. But the real revolution was frequency modulation itself. FM technology, developed by Edwin Armstrong and licensed for military use, eliminated the static inherent to AM systems. Electrical noise that rendered German radios useless became irrelevant. Even under artillery fire, American tank crews communicated clearly. Words did not dissolve into static, commands did not vanish into interference. Communication remained reliable when it mattered most. On November 8, 1942, Operation Torch brought American armored units into North Africa. Sherman tanks of the 2nd Armored Division rolled ashore near Safi and Fadala, equipped with SCR-508 radios that would soon expose the limitations of German communications. The Afrika Korps, despite its experience and reputation, operated under severe radio constraints. In a standard German tank platoon of 5 vehicles, only 1 or 2 possessed full transceivers. The rest could listen, but not speak. German platoon control depended on rigid hierarchy. Orders flowed downward from the platoon leader. Subordinate tanks acknowledged instructions through movement rather than voice. When command tanks, easily identified with their multiple antennas, were destroyed, coordination collapsed instantly. Entire platoons became isolated groups of individual vehicles. Against American units where every tank could assume command, this weakness proved fatal. The Battle of Kasserine Pass, fought between February 14 and 24, 1943, provided the first large-scale demonstration of American radio superiority. Though tactically a German success, the engagement revealed capabilities that unsettled German observers. Scattered elements of the U.S. 1st Armored Division maintained coordination across distances exceeding 50 miles. Tank crews unfamiliar with one another coordinated movements, exchanged warnings, and called for artillery through clear FM communication. German signals intelligence intercepted American transmissions and noted their unusual clarity. Reports from the 10th Panzer Division confirmed that American units maintained effective radio contact at ranges where German equipment produced only noise. More alarming was the realization that every American tank appeared capable of transmitting, not merely command vehicles. The implications of that discovery would reshape armored warfare, though German commanders would not fully grasp them until it was too late. German armored doctrine had been built around the assumption that radio communication was a scarce and fragile resource. The Fug-5 radio, operating on amplitude modulation between 27.0 and 33.3 MHz, had been designed in an era when tanks were expected to move slowly and operate within tight formations. Its 10-watt transmitter could reach 2 to 3 kilometers under ideal stationary conditions. Once tanks began moving, vibration and electrical interference reduced effective range to a few hundred meters. Every spark from an ignition system, every rotation of steel tracks injected noise into the signal. German engineers accepted these limitations as unavoidable. American engineers did not. The SCR-508's frequency modulation system fundamentally altered the physics of battlefield communication. Instead of encoding voice information in signal amplitude, where noise overwhelmed clarity, FM encoded information in frequency deviation. Electrical interference that crippled German radios simply failed to disrupt American transmissions. Voices remained intelligible even while engines roared and artillery shells detonated nearby. What German tank crews experienced as chaos, American crews experienced as continuity. German intelligence officers noticed the difference but failed to understand its source. Intercepted American radio traffic exhibited remarkable clarity and discipline. Tank units coordinated movements across terrain where German formations would have fragmented. Intelligence assessments attributed this performance to superior training rather than superior technology. The conclusion was comfortable and catastrophically wrong. In February 1943, at Kasserine Pass, German commanders believed they had shattered American armored forces. U.S. units withdrew under pressure, equipment was abandoned, and command structures temporarily collapsed. Yet even during retreat, American tanks maintained radio coordination. Units separated by terrain obstacles continued exchanging information, reporting enemy movements and reorganizing dynamically. German observers saw confusion. What they did not see was recovery happening in real time through invisible radio links. The German radio architecture could not support such adaptability. With most tanks unable to transmit, situational awareness flowed only in one direction. Platoon leaders issued orders but received little feedback. If a subordinate tank encountered an unexpected threat, there was no way to report it. If a command tank was destroyed, the platoon effectively ceased to function as a coordinated unit. German armored forces relied on visual signals, prearranged plans, and rigid execution, methods that collapsed under fluid conditions. American tank units operated differently. Every Sherman carried a full transceiver. Any tank commander could report contacts, request fire support, or assume command if necessary. Communication was horizontal as well as vertical. Information moved laterally between tanks, not just up and down the chain of command. This created redundancy. The destruction of a single vehicle did not break the network. The SCR-508's design reinforced this flexibility. Dual BC-603 receivers allowed commanders to listen simultaneously to platoon and company nets. Orders from higher headquarters flowed down while situational reports flowed up and sideways. The BC-606 intercom system connected all crew members internally, allowing gunners, loaders, and drivers to relay observations instantly. Throat microphones and noise-canceling headphones made speech intelligible even during combat. Many German tanks lacked intercom systems entirely, forcing crews to rely on hand signals or physical contact inside cramped fighting compartments. Power management further widened the gap. The SCR-508 operated on either 12 or 24-volt systems, automatically adapting to available vehicle power. Its dynamometer power supply filtered electrical noise before it reached sensitive components. German radios powered directly from vehicle electrical systems absorbed every spark as interference. American engineers treated electrical noise as a solvable problem. German engineers treated it as an unavoidable reality. As American forces moved from North Africa into Italy in September 1943, terrain that should have neutralized radio advantages instead amplified them. Mountain valleys created multipath interference that rendered German AM radios nearly useless. Signals reflected off rock faces and terrain features, producing distortion and fading. FM radios handled these conditions far better. American tanks coordinated movements through valleys and over ridge lines where German formations lost contact entirely. During the advance towards Cassino, American armored units demonstrated coordination that German doctrine insisted required visual contact. Platoons separated by hills synchronized attacks with precision timing. After-action reports from the U.S. 1st Armored Division described routine communication at distances where German radios failed completely. German officers observing these engagements concluded incorrectly that American crews must be using extensive pre-arranged planning. The reality was simpler and more dangerous. They were talking. By June 6, 1944, American radio superiority extended beyond armored formations. As Sherman tanks rolled off landing craft in Normandy, SCR-508 radios maintained contact with naval gunfire support. Fire missions coordinated directly from tanks to ships offshore, coordination impossible under German communication doctrine. Yet Normandy also exposed a critical weakness. Tank radios operated on different frequency bands than infantry radios. The SCR-300 backpack radios used by infantry operated between 40.0 and 48.0 MHz, incompatible with tank frequencies. This gap proved deadly in the bocage. German infantry armed with Panzerfausts could approach American tanks undetected, while nearby American infantry had no direct way to warn tank crews. The problem was identified quickly and solved with characteristic American pragmatism. Tank crews welded steel ammunition boxes to the exterior of Sherman hulls and mounted EE-8 field telephones inside. Infantry could plug directly into the tank's internal communication system and speak to the crew. By Operation Cobra in late July 1944, this innovation transformed tank-infantry cooperation. Communication barriers that German doctrine considered inherent vanished in weeks. The consequences would soon be unmistakable.
July 25, 1944, marked the moment when American radio superiority transitioned from advantage to dominance. Operation Cobra, the breakout from Normandy, unleashed armored forces into terrain that should have favored German defenders. The bocage had neutralized mobility for weeks. Narrow lanes, thick hedgerows, and limited visibility reduced engagement ranges to under 100 meters. German commanders expected chaos once American units pushed beyond prepared plans. Instead, they encountered coordination at a scale they had never witnessed. The U.S. 2nd Armored Division, commanded by Major General Edward H. Brooks, advanced with more than 200 Sherman tanks linked by continuous radio contact. Platoons maneuvered independently, yet remained synchronized with battalion and divisional command. Tanks responded to threats reported by units miles away. When a German anti-tank gun opened fire, its position was reported, relayed, and engaged by artillery within minutes. German crews described the experience as fighting an enemy that seemed to see through hedgerows. The Panzer Lehr Division, Germany's most technologically advanced armored formation, faced this system head-on. Lehr's Panthers and Panzer IVs were superior in armor and gun performance. But most Lehr tanks operated without radios. Others relied on AM sets plagued by interference. Coordination depended on visual contact in a terrain where visibility barely extended beyond a single hedgerow. German platoons fought as isolated clusters rather than integrated formations. The imbalance was devastating. American armored doctrine emphasized command comments, temporary task forces assembled for specific missions. These formations depended entirely on radio coordination. Units could be reorganized on the move. Tank destroyers, artillery observers, and infantry elements integrated seamlessly. German commanders could not comprehend how American units shifted so fluidly. Their own doctrine demanded rigid organization because communication limitations made flexibility impossible. This disparity reached its clearest expression during the Battle of Aricourt in September 1944. The U.S. 4th Armored Division faced multiple German Panzer brigades equipped with Panther tanks that outmatched Shermans in every technical specification. Yet over 3 weeks of fighting, American forces destroyed 281 German armored vehicles while losing only 41 Shermans, a kill ratio approaching 7-to-1. The explanation lay not in armor or gunnery, but in information flow. Every American tank could report enemy positions instantly. Forward observers embedded in Sherman command tanks coordinated artillery strikes that arrived within 3 to 5 minutes. Tank destroyers maneuvered based on radio reports from units they could not see. German formations, lacking reliable communication, attacked piecemeal and were destroyed in detail. German intelligence reports consistently misdiagnosed the problem. A September 1944 assessment concluded that American tank coordination resulted from excellent radio discipline and extensive training. The report failed to identify the technological foundation of that coordination. German planners continued targeting command tanks based on antenna configurations, unaware that every Sherman functioned as a command vehicle. As American forces raced across France, radio networks allowed unprecedented operational tempo. The Third Army's rapid advance depended on maintaining command across hundreds of miles. Orders flowed instantly, supply routes adjusted dynamically. German forces, reliant on telephone lines that Allied aircraft routinely severed, could not respond with comparable speed. By March 1945, as American units approached the Rhine, communication superiority reached its zenith. When elements of the 9th Armored Division discovered the Ludendorff Bridge at Remagen intact, radio reports reached 1st Army headquarters within minutes. Entire corps shifted orientation within an hour. German forces, dependent on broken landlines and courier systems, reacted too slowly to contest the opportunity. American tanks established a layered radio defense around the bridgehead. Platoons from different battalions integrated seamlessly. Fire missions overlapped without confusion. German counterattacks arrived fragmented and unsupported. The bridgehead expanded while German coordination collapsed. The encirclement of the Ruhr pocket in April 1945 demonstrated the final outcome of this invisible war. Armored columns from the 1st and 9th Armies executed a complex double envelopment coordinated entirely on radio. Inside the pocket, more than 300,000 German troops found themselves isolated as communications failed. American fighter bombers, guided by radio-equipped forward controllers, systematically destroyed remaining command nodes. Field Marshal Walter Modell's final messages reflected the collapse. No contact with adjacent units, no communication with higher headquarters, coordination impossible. For American tank crews, radio connectivity transformed the psychological experience of combat. Even when physically isolated, they remained part of a larger network. German crews experienced the opposite, fighting alone within battles they could not comprehend in full. After the war, technical intelligence confirmed what combat revealed. German tanks often matched or exceeded American armor and firepower, but their communications lagged years behind. An American Army technical report concluded that German tank radios were approximately 5 years inferior in design and deployment. The verdict was unmistakable. America had not built the best tank. America had built the best connected army. The magnitude of America's communication advantage became fully visible only when production statistics were examined after the war. While German industries struggled to equip a fraction of its armored forces with radios, American factories treated communication equipment as inseparable from the tank itself. There was no concept of a radio tank and a non-radio tank. Every Sherman was built as a communications platform from the outset. This achievement rested on industrial mobilization centered in Chicago. The Galvin Manufacturing Company, renamed Motorola in 1947, had entered the war as a producer of civilian car radios. Converting to military-grade production required an unprecedented technical leap. Tank radios would be subjected to heat, vibration, moisture, electrical noise, and physical shock far beyond civilian design parameters. Failure was not acceptable. Each SCR 508 family radio required 2,748 individual components manufactured to exact tolerances. The BC 604 transmitter alone contained hundreds of capacitors and resistors, all of which had to maintain performance under combat stress. Crystal oscillators had to remain stable despite temperature swings that ranged from desert heat to European winter cold. Assembly lines were redesigned, testing protocols expanded, and quality control tightened beyond anything pre-war electronics manufacturing had known. The output figures tell the story. In 1942, American factories produced approximately 3,800 SCR 508 family sets. In 1943, production rose to over 11,000 units. In 1944, output exceeded 24,000 sets. Total wartime production surpassed 50,000 tank radio systems. This volume ensured that all 49,324 Sherman tanks manufactured during the war received fully integrated FM radio equipment. No other nation came close to this level of universal deployment. German production statistics revealed the contrast. Germany manufactured roughly 12,000 medium and heavy tanks during the war. Fewer than 6,000 FUG-5 transceivers were produced. Most were allocated to command vehicles, leaving regular tanks without transmission capability. Even elite Panzer divisions often fielded fewer than one fully equipped radio per platoon. The technical differences extended beyond quantity. German radios relied on variable capacitor tuning, which drifted constantly under vibration. American radios used crystal-controlled frequencies that remained locked even during prolonged movement and combat. German crews frequently lost contact without realizing it. American crews knew instantly if a connection failed. Range figures underscore the disparity. An American SCR 508 maintained reliable communication at 7 miles while moving and up to 15 miles when stationary. German FUG-5 sets struggled to reach 1 mile in motion and rarely exceeded 3 miles when stopped. Fire missions reflected this gap. American units could coordinate artillery strikes in 3 to 5 minutes. German units required 15 to 30 minutes under ideal conditions. The cumulative effect reshaped armored warfare. American doctrine evolved around communication as a force multiplier. Command commands operated as fluid networks rather than fixed formations. Tank crews shared information continuously, creating what modern analysts would recognize as distributed situational awareness. German units, bound by communication scarcity, remained rigid and reactive. German commanders recognized the problem but lacked solutions. Heinz Guderian, architect of Blitzkrieg and Inspector General of Armored Troops, acknowledged the communication deficit in late 1944. Yet German industry could not deliver the radios his doctrine demanded. Competing priorities, resource shortages, and Allied bombing ensured the gap would never close. After Germany's surrender, American and Soviet technical teams evaluated captured equipment. Both reached similar conclusions. German tanks were formidable as individual machines, but catastrophically disadvantaged as components of a coordinated force. Soviet analysts, in particular, chose to copy American radio designs rather than German systems for post-war development. The implications extended beyond World War II. Modern armored doctrine rests on principles proven by the SCR 508. Universal communication, redundancy, and networked coordination outweigh individual platform superiority. German post-war doctrine absorbed this lesson fully. Every Leopard tank produced by the Bundeswehr carried comprehensive communication suites as standard equipment. A Bundeswehr training manual explicitly stated that information dominance outweighs platform performance. The battlefield of 1943 had revealed a truth that would define modern warfare. Connection equals survival. Isolation equals defeat.
The psychological consequences of this communication imbalance were profound and often overlooked in traditional battlefield analysis. American tank crews entered combat with a constant awareness that they were part of a larger, responsive system. Even when physically separated from friendly units by terrain, smoke, or enemy fire, they remained connected. Orders, warnings, and requests for support flowed continuously through radio networks. Isolation was rare and temporary. German tank crews experienced the opposite condition. Combat unfolded in fragments. A tank advanced, fired, maneuvered, and withdrew largely on its own initiative, often without knowing what neighboring units were doing. When contact with a platoon leader was lost, crews reverted to prearranged plans or improvised based on limited visual information. The battlefield became a series of disconnected engagements rather than a coherent fight. Otto Carius, one of Germany's most successful tank commanders, later described the frustration of limited communications in his memoirs. While he focused primarily on tactics and terrain, his accounts consistently reveal the isolation German crews endured. Orders arrived late or not at all. Situational awareness depended on personal observation rather than shared intelligence. Even experienced commanders struggled to coordinate under such constraints. American crews fought differently. Radio contact allowed rapid adaptation. A Sherman encountering unexpected resistance could alert neighboring units instantly. Tank destroyers repositioned based on live reports. Artillery observers embedded in armored units coordinated fire support without delays imposed by couriers or landlines. The result was a tempo of operations German forces could not match. This advantage shaped entire campaigns. During the rapid advance across France in late summer 1944, American armored columns maintained momentum because communication networks extended across vast distances. Units advancing dozens of miles in a single day remained under centralized control while retaining local initiative. German commanders repeatedly underestimated American speed because they assumed such advances would cause coordination breakdowns. They did not. By early 1945, the communication gap influenced strategic outcomes. As Allied forces crossed into Germany, American radio coordination allowed exploitation at a pace that collapsed remaining defenses. German units retreating toward the Rhine found themselves outmaneuvered not by superior firepower, but by superior information flow. When bridges were seized, crossings secured, or gaps identified, responses propagated instantly through American networks. Inside German formations, communications collapsed under Allied pressure.
Telephone lines were cut by air attacks, radio nets fragmented under interference and equipment shortages. Commanders lost contact with subordinates and higher headquarters alike. Orders became irrelevant once issued because situations changed faster than information could travel. Field Marshal Walter Model's final operational messages reflected this breakdown. Reports spoke of continued fighting but admitted coordination was impossible. Units fought on without knowing whether support existed or retreat routes remained open. In contrast, American units operated with near real-time awareness of friendly positions, enemy movements, and logistical status. Post-war analysis confirmed that this disparity affected casualty rates. American armored units consistently achieved favorable exchange ratios even when facing technically superior German tanks. Faster coordination reduced exposure time, improved fire concentration, and enabled timely withdrawal when necessary. German units, unable to coordinate responses, suffered losses disproportionate to their tactical skill. The implications extended into post-war military thought. Analysts increasingly recognized that warfare had entered an era where information dominance could outweigh traditional measures of combat power. Armor thickness, gun caliber, and individual vehicle performance mattered less than the ability to share information instantly and act collectively. The SCR-508 radio symbolized this shift. Weighing 181 pounds, it did not fire a single shot, yet it multiplied the effectiveness of every weapon system connected to it. A Sherman without a radio was merely adequate. A Sherman integrated into a network became part of a force greater than the sum of its parts. German failure to recognize this reality in time stands as one of World War II's most consequential intelligence oversights. Despite repeated battlefield evidence, German leadership never prioritized solving the communication deficit. Production continued to favor superior individual platforms over integrated systems. The result was an army of powerful machines fighting alone against a networked opponent. By the time German commanders understood the nature of the disadvantage, adaptation was impossible. The industrial base required to correct the imbalance no longer existed. The electromagnetic spectrum had become a battlefield Germany could no longer contend.
After Germany's surrender, Allied technical intelligence teams conducted exhaustive examinations of captured armored vehicles and communication equipment. Their findings confirmed what battlefield experience had already demonstrated. German tanks frequently possessed superior armor protection and more powerful main guns, but their communication systems were critically deficient. A United States Army Technical Intelligence Summary concluded that German armored radio equipment lagged approximately 5 years behind American systems in both design and battlefield effectiveness. The absence of frequency modulation, limited transmitter availability, poor electrical suppression, and inconsistent crew training created vulnerabilities that no amount of tactical skill could fully compensate for. German tanks were often technologically impressive but operationally isolated. American tanks, by contrast, functioned as interconnected elements within a coherent combat system. Soviet evaluators reached similar conclusions. When the Red Army examined captured German equipment, they rejected German radio designs in favor of American-style systems. Post-war Soviet armored doctrine emphasized universal radio installation and centralized coordination, lessons learned indirectly from American battlefield performance. The same conclusions were reached across NATO militaries in the years that followed. Production statistics illustrate the scale of the disparity. The United States manufactured more than 50,000 SCR-508, SCR-528, and SCR-538 tank radio sets during the war. This number closely matched Sherman tank production, ensuring full deployment across all armored units. Every American medium tank entered combat equipped with reliable FM communications. Germany, by contrast, produced approximately 6,000 FUG-5 transceivers, while manufacturing roughly 12,000 medium and heavy tanks. Fewer than 1 in 5 German tanks carried full two-way radio capability. The operational consequences were measurable. American fire missions averaged 3 to 5 minutes from request to impact. German artillery coordination often required 15 to 30 minutes, assuming communication was possible at all. American armored units achieved full coordination across formations. German units operated with partial or non-existent communication, forcing rigid planning and reducing adaptability. The SCR-508 established principles that continue to govern armored warfare today. Modern main battle tanks carry digital communication suites that trace their conceptual lineage to this system. Universal deployment, reliable coordination, and integration across units remain foundational. The German Bundeswehr, rebuilt in the 1950s, explicitly prioritized communications based on World War II lessons. Every Leopard tank has carried comprehensive radio systems as standard equipment. Modern conflicts have validated the same principle. During the 1991 Gulf War, coalition forces destroyed Iraqi armored units equipped with individually capable Soviet-designed tanks but inferior communications. In 2003, network-centric warfare again demonstrated that information dominance defeats platform-centric approaches. These outcomes echoed lessons learned on North African plains, European hedgerows, and German roads decades earlier. The story of Sherman tank radio superiority represents a decisive victory in the electromagnetic spectrum. It proved more influential than advantages in armor thickness or gun caliber. German tank crews fought their war largely unaware of this transformation, discovering too late that every Sherman was not merely a vehicle, but a node in history's first true armored battlefield network. The SCR-508 transformed the M4SH Sherman from an adequate medium tank into a component of a distributed weapons system. That system included every other American tank on the battlefield, linked by invisible waves that transmitted information faster than any human messenger. This collective intelligence allowed American forces to react, adapt, and overwhelm opponents who often possessed superior individual machines. German forces learned this lesson through bitter experience. At Kasserine Pass, in Italy's mountains, across France's hedgerows, and during the final battles inside Germany, American tanks demonstrated coordination that German doctrine considered impossible without visual contact. The Wehrmacht never developed an effective counter because it never fully grasped the technological foundation of the advantage. Field Marshal Wilhelm Keitel's reported remark at surrender that Germany knew how to build better tanks, but America knew how to make them work together, captures a fundamental truth, whether precisely quoted or not. The United States built not just 49,324 Sherman tanks, but 49,324 connected combat nodes operating as unified formations. Historians often associate network-centric warfare with late 20th century conflicts, but its origins lie in 1942. The moment the first Sherman equipped with an SCR-508 entered combat, warfare changed. From that point forward, the side with superior communications would defeat the side with superior individual weapons. Connection would equal survival. Isolation would equal defeat. German leadership failed to recognize this shift, despite repeated evidence. They continued investing in technically superior platforms that fought alone, while American forces fielded adequate machines that fought as coordinated teams. By the time German commanders understood the nature of the disadvantage, industrial reality made correction impossible.
In the end, electromagnetic waves carried by American FM radios proved more powerful than armor-piercing rounds fired from German guns. The ability to coordinate, to share information instantly, and to act as a unified force determined victory more reliably than any visible superiority in armor or armament. The Sherman tank's radio superiority changed warfare permanently. It established the principle that in modern combat, connection is power. German forces across 3 continents learned this lesson too late. The Americans did not merely outnumber them, they out-connected them.